Okay, so we have trig functions of any angle. We briefly talked about trig functions, and I mentioned that we're going to look at them a lot of different ways. So today we're going to start using right triangles to look at them. So we're going to treat this as theta. Now, keep in mind that theta changes your perspective. So that's theta. Where you have this idea of from theta, the side that you're looking to is your opposite side. So opposite. Your side that's juxtaposed to it is your adjacent side. And then your diagonal, which is the longest side, is always your hypotenuse. All right. Those are the three things you need to know. You've sure seen this before, but maybe you didn't have to go this deep into it. So when we talk about the trig functions, right? So the 6 trig functions. This is what we need to know. All right. We have sine, theta. We have cosine, theta. We have tan, theta. And I always write their reciprocal function straight across from them, so I can't get confused on what I need to do. All right, but I use theta for all of them because theta is my reference point. Theta determines what's going to happen. So theta for sine is always equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And finally, tangent is opposite over adjacent. If you've heard the term SOHCAHTOH, SOHCAHTOH, all right, always determines those first three. From there, you just flip them. So this becomes hypotenuse over opposite. This becomes hypotenuse over adjacent. And last but not least, this becomes adjacent over opposite. So that's pretty straightforward. All right, that's nothing new. You also have the reciprocal functions, which I'll mention real quick. Reciprocal. So with our reciprocal functions, you have cosecant theta, you have secant theta, and you have cotangent theta. It's important to have this because if you're putting these into a calculator, this is how you need to do it. So if you have like cosecant of 30 degrees, then you need to actually plug it in as 1 over sine of your degree value. Same thing with secant would be 1 over cosine. And cotangent would be 1 over tangent. All right, so those are all your new little properties you have to know about. And again, we talked about these first 6 last week, but we described it as, oh, sine is y, cosine's x, tangent is y over x. Guess what? Still the same thing, because sine is y, opposite over hypotenuse, cosine is x over hypotenuse, and tangent is y over x. All right, so we didn't really change anything. We just changed the notation that we're using. But the math is still going to be the same. All right. So an example of what they'd ask you to do. If they say, given the following triangle, find all 6 trig functions. All right, this is pretty straightforward. So if I have a triangle that is written like this, and I say this is theta, that's my right angle, I have 3 and I have 4. All right, I need to find the other side. If I need to find the other side, I'm going to use what theorem? while you think about that. If you know, you can post it in our Discord chat, I suppose, if you don't feel like talking. If you don't know, you're going to find out here in a few minutes, or a few seconds, I suppose. All right, good job, everybody. It's Pythagorean theorem. All right, because you have a squared plus b squared equals c squared. So I have that, which gives me the square root of 9 plus 16, which is the square root of 25. So 5 equals c. So now I know all the sides. And once I know all the sides, I can go through and write out what each thing is. So for sine, opposite over hypotenuse, so 4 over 5. Adjacent over hypotenuse for cosine, opposite over adjacent for tangent. Once you know all those things, you get to just plug everything, or you just get to flip everything over from the other side. So 5/4, 5/3, 3/4. All right, so this shouldn't be anything too horribly crazy. Hopefully, this is pretty straightforward. Do we have any questions over this so far? Okay. So that's the basic idea, that you'll be given a triangle, find the others, or find all 6 trig functions. That's pretty simple. I also mentioned last week when we started talking about unit circle that we need to go back and talk about special triangles. So you have 2 special triangles that you need to think about. You have special triangles. All right, so for special triangles, you have 30, 60, 90, and you have 45, 45, 90. So let's talk about our 30, 60, 90 first. So our 30, 60, 90 triangle. We're not too concerned about theta at the moment. We are going to call, let me use my pen so I can actually make it where this is visible, 60 degrees and make this 30 degrees. All right. It is given that if this side is 1, this side is 2, and then when you do Pythagorean theorem, you find out that this side is the square root of 3. And if you think about what happens on the unit circle, like sine of 60. So if we look at sine of 60 degrees. All right, well, sine of 60 is opposite over hypotenuse, so it's square root of 3 over 2. That's how they get that value at 60 degrees. They just use special triangles. Well, if I use cosine of 30, that's interesting. That's going to be adjacent over hypotenuse. I get square root of 3 over 2. If you look at the unit circle, those are the 2 values that flip-flop. All right, and that was what I was talking about last week when we briefly talked about unit circle, is that all those coordinate pairs that are picked in each quadrant come from these special triangles. That's why we use the specific values of 30, 45, 60, 90, because we can find those relatively easily. So hopefully that provides some clarity from last week. Now, if we go through and we talk about other special triangle, and our other special triangle is 45, 45, 90. All right, which obviously that's a 90-degree angle, which makes these 2 angles 45. If you know those 2 angles are 45 degrees, then we know that this side, where's my black marker, is 1, and this side is 1 because of the way angles work. The sides have to be the same. If you do Pythagorean theorem, that means this side is going to be square root of 2. All right, and again, I can go through and I can look at, well, let me look at sine of 45. Well, I can pick either one. It doesn't matter. If I pick sine of 45, I get 1 over the square root of 2. But we talked about last week, I can't have a square root in my denominator. I have to go through and rationalize it, which means I need to multiply the numerator and the denominator by square root of 2. So I get square root of 2 over 2. Same thing's going to happen for cosine, because at 45 degrees, the x and y coordinates are exactly the same. Hopefully that provides some clarity about unit circle stuff. Okay. I'm going to flip the page in like a couple seconds, so if anybody's writing that down, they can have it. I want to talk about another example. I'm going to read the word problem rather than write it all out, because I think I would use a whole page using my markers to write it out. And we're just going to draw a triangle and solve it, so you can have an idea, if you have a word problem, what you need to do. All right, so they have the word problem, and it's about distance to a fire cave, and the fire cave is inside of a tree, which seems like a bad place for a fire to be. So our word problem example is the following. Let's go through this. It says massive trees can survive wildfires that leave large caves in them. This is from National Geographic, October 2009, on page 32, in case you want to go look at that. A hiker observed scientists measuring a fire cave in a redwood tree in Prairie Creek Redwood State Park. He estimates that he is 80 feet from the tree. So our little dude is 80 feet. So our scientist, this dude, he's down here. He has this, and let's say he has some binoculars. He is 80 feet from this tree that is caught on fire. It has survived, and it now has a fire cave in it. This is a terrible tree, but like, think about it, right? It's been on fire. It's like burnt up. It has all these like squiggly branches that maybe survived. I don't know. All right, cool. Terrible tree. You know, we out here. We're doing some art. This is our cave of where the fire has happened. All right, cool. In fact, this tree, according to this geographic picture, apparently has green sort of its shrubbery back. All right, now you can feel like you've seen what I'm seeing with my word problem. Okay. So he's 80 feet away from the tree, and that angle between the ground and the line of sight in the scientist is 60 degrees. So from him to this cave, that is a terrible, not drawn well line. That's almost better. There we go. We did it. All right, and this is 60 degrees. Approximate how high the fire cave is. So we are looking for H. All right. You have a few things. You have an angle. You have the adjacent side. You are looking for the opposite side. So you need to find a trig function that uses opposite and adjacent. If you go back and look from our first page, opposite and adjacent right here, use tangent. So we're going to say tangent of 60 degrees equals our height over 80. Well, if I want to solve for height, I move that over and say 80 tangent of 60. Make sure your calculator is in degree mode, and you're going to get a height. And that height is 139 feet. It's approximate value. Okay, so this is all the little nuances we can use our trig stuff for. It's in this case right now, we're just specifically using right triangles. Everything else in this section is plugging it into a calculator. All right, and I'm not too concerned about that. You guys can do that. We've done a few problems like that already over the past few weeks. There's also some discussion about cofunction identities. I'm not going to write all those out. Cofunction identities are this idea on the previous page when I did, well, sine of 60 and sine of 30 hold the same value. So we have some different cofunction identities from that. There's no reason to write all those properties out because really, if you can do the math, you don't really need the identity for that. But that is 6.1. All right, nice, easy, and to the point. So hopefully that is helpful for that. And I'm going to post some work for you guys here briefly.